Chingua University's groundbreaking ACCEL chip shatters the norms of computing, boasting a 3,000 times performance leap over current tech. Could this be the dawn of a new era in global chip technology? Stay tuned, because the story behind this monumental advancement could redefine the future of technology and shift the global balance in chip innovation. On November 4th, it was announced that a team of researchers from Chingua University had achieved a significant breakthrough following extensive collaborative research. They successfully addressed the physical limitations of traditional computer chips by introducing an innovative computing framework that combines optics and electronics. Their achievement resulted in the creation of the world's first all-analog photonic electronic intelligent computing chip, which they named ACCEL. Experimental tests revealed that this chip exhibited exceptional computational capabilities in tasks related to intelligent visual object recognition, surpassing the performance of current high-end commercial chips by an astonishing factor of over 3,000. This accomplishment not only marks a pioneering development, but also paves the way for the creation of ultra-high-performance chips. The research team accomplished this by merging optical computing, based on electromagnetic wave propagation, with analog electronic computing. Following Kirchhoff's laws, they overcame three significant international challenges: the integration of computer shooting units on a large scale, efficient nonlinearity, and the establishment of high-speed optoelectronic interfaces, all within a single chip while maintaining superior task performance. The chip achieves remarkable levels of computational efficiency and speed. To ensure the credibility of their experimental data, the research team conducted extensive measurements and verification procedures. They applied cutting-edge cross-layer collaborative technologies for intelligent visual interactions, a first in the field, and harnessed equivalent computing power to precisely evaluate energy efficiency and latency data. ACCEL boasts three primary advantages. Firstly, it offers unparalleled high performance. Based on experimental measurements, the ACCEL chip's system-level computational power surpasses that of existing high-performance chips by a staggering factor of 3,000. To put this into perspective, it's equivalent to condensing an 8-hour journey on the Beijing-Guangzhou high-speed rail into a mere 8 seconds. Secondly, it boasts ultra-low power consumption. The system-level energy efficiency measures an impressive 74.8 peta/ops/W, representing a remarkable 4 million-fold improvement over existing high-performance GPU and TPU architectures. To illustrate, the power required to sustain existing chips for 1 hour can now power ACCEL for more than 500 years. This breakthrough positions the all-analog photonic electronic intelligent computing chip as one of the world's most energy-efficient chips, signaling a new direction for the global chip industry. Thirdly, it offers exceptional cost efficiency. The photonic electronic fusion chip's optical component boasts an incredibly narrow minimum line width, measuring only a few hundred nanometers, while the circuit component adopts a 180 nanometer C process. This results in performance enhancements of several orders of magnitude when compared to high-performance chips based on 7 nanometer technology. Additionally, the materials used are readily available, and the production cost is significantly lower than that of its counterparts. The successful development of the all-analog photonic electronic intelligent computing chip marks not just a technological milestone, but also carries profound implications for its practical applications. This chip holds the potential for widespread utilization in fields such as artificial intelligence, AI, big data, and other areas, offering robust support for their rapid advancement. As technology, particularly in artificial intelligence and big data, continues to advance, the all-analog photonic electronic intelligent computing chip is poised to become a major driving force behind the progress of these fields. This achievement is anticipated to propel the global chip industry forward and provide substantial support for the advancement of artificial intelligence, big data, and related domains. The outlook for chip technology development in China appears promising, and the United States is unlikely to hinder it. According to reports from foreign media, Bern J. Lin, the former Vice President of Research and Development at TSMC, has stated in an interview that the United States cannot impede China's progress in chip technology. He also expresses confidence in China's ability to leverage existing equipment to develop even more advanced 5 nanometer processes. Lin's remarks have surprised foreign media observers. His statements come in the wake of Huawei's development of the Kirin 9000s, which is equivalent to a 7-nanometer process. Lin believes that this achievement underscores the remarkable resilience and originality of the Chinese chip industry, suggesting that it is not limited to the 7-nanometer process and could potentially achieve a 5-nanometer process. Lin is widely recognized as the pioneer of immersion lithography at a time when Japanese companies held a monopoly in the lithography machine industry, with Canon and Nikon collectively dominating nearly 80% of the market share through dry lithography machines. Lin introduced the concept of immersion lithography. However, due to the vested interests of Japanese companies, they did not fully embrace Lin's immersion lithography technology. This led to challenges as ASML approached TSMC, resulting in a collaborative effort to develop immersion lithography machines. By 2008, ASML's immersion lithography machines had gained a leading position, leading to a sharp decline in Japan's lithography machine industry. This collaboration not only revolutionized the lithography machine industry, but also propelled TSMC to make significant advancements. TSMC's chip manufacturing processes underwent breakthroughs, establishing itself as a leader in the chip foundry industry. Consequently, Bern J. Lin has earned recognition as the pioneer of immersion lithography. In recent years, the Chinese chip industry has faced constraints related to lithography machines. However, substantial progress has been made across various facets of chip manufacturing, including the development of etching machines capable of achieving the 5-nanometer level. These breakthroughs at different stages of chip production underscore the solid technological foundation of the Chinese chip industry and its confidence and capacity to drive the advancement of the domestic chip industry ecosystem. The introduction of the Kirin 9000's chip has been regarded by foreign media as a significant leap in lithography machine technology for China. This revelation came as a surprise to foreign media since lithography machines are exceptionally intricate devices. For instance, the ASML EUV lithography machine, a prominent example, involves a staggering 100,000 components and requires collaboration from 5,000 companies worldwide. In contrast, China has achieved mass production of lithography machines, solely relying on its domestic supply chain. The United States has made efforts to employ lithography machines as a means to impede China's chip industry. This included urging the Netherlands to restrict the export of advanced lithography machines to China. However, following the launch of Huawei's Kirin 9000's chip, the Netherlands unexpectedly granted ASML a license in September, permitting the export of more advanced 2000i lithography machines to China. Lin's statements have prompted foreign media to reevaluate the Chinese chip industry. Given his profound understanding of lithography machine technology and his background as the former Vice President of Research and Development at TSMC, his endorsement of the Chinese chip industry carries considerable weight. Lithography machines are pivotal in the realm of existing silicon-based chip technology, which is largely dominated by the United States. China is well aware that its research and development efforts in silicon-based chip technology have primarily followed the footsteps of the United States. Consequently, China is actively striving to bolster its position in the existing silicon-based chip industry supply chain, while simultaneously accelerating the development of an autonomous domestic silicon-based chip industry supply chain. Recognizing the limitations of replicating the American model, China is vigorously researching and developing more advanced technologies, such as photonic chips and quantum chips. China has already established the world's first photonic chip production line in Beijing and is in the process of constructing a quantum chip production line in Hefei. The ACCEL photonic chip, a creation of Chingua University, serves as a prime example of China's exploration into innovative technologies within the chip industry. In the domains of photonics and quantum chip technologies, China has caught up with the United States and Europe, with expectations of achieving commercialization of these advanced chip technologies within the next decade. By that time, existing chip equipment, like photolithography machines, will become obsolete and cease to be a hindrance to China's chip development. Consequently, it is no longer realistic for the United States to continue restricting China's chip development in the domain of existing silicon-based chip equipment. China can persist in independently developing silicon-based chip technologies to reduce reliance on imports, while simultaneously establishing a fully self-sufficient technical ecosystem in the field of advanced photonics and quantum chip technologies. Chinese chips will not be perpetually bound by American technology and are poised to chart new paths in chip technology in the future. The potential for China to overtake and break through the barriers posed by American technology is substantial. Foreign media believe that the United States cannot halt the momentum of China's chip development. What are your thoughts on the trajectory of Chinese technology on the global stage? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the Revel Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Remember, as we delve into the realm of technology, the possibilities are limitless, and the future is filled with exciting discoveries. Keep exploring.